All right, folks, we're going to talk about compound interest, the geometric sum formula. It's written right here, and you can see that I've labeled everything already. So we're trying to find whatever the future amount is going to be. Typically, this number right here, that's a sub 1, so it's like a tiny 1 on the bottom, which just means the first term. The R is the interest rate, like always. So if the interest rate was 6%, then you would want to write something like 1.06. All right, so just keep that in mind. And then N is the number of compounding periods. So whether it's months or years, however it's set up, you'll use the total number there. All right, so that's the formula. We're not going to use it first, though. We're going to actually use a previous formula first. So get that down and we'll keep going. So it says, suppose that we want to invest $100 into an account that averages 1% monthly interest. How much would we have after 1 month? And so here's the big formula, the compound interest formula, where amount is equal to the principal of the starting amount, a rate divided by the number of periods per year times number of years. All right, so that's the normal formula, and then we're going to kind of see how to use it in this example. So, well, it's $100, so we can write $100 for the initial amount, 1 plus, and it says 1% monthly interest, and so it's already converted into monthly interest. So we're going to write just 0.01, and so we don't have to convert it from yearly to monthly interest. And then it says, how much would we have after 1 month? And so what we're going to do here is we're going to write a 1 because we don't want to know the amount after a year. We want to know the amount after 1 month. And since it's 1% per month, and we're going to raise it to the first power, and that'll give us the amount after 1 month. So 1.01 to the first power, that's all we got to do. And so that's going to give us 101. So that's pretty straightforward, pretty basic. Same thing. What about after 2 months? Well, we take the same formula and we're just going to do 1.01, and you guessed it, right, to the second power, and that'll give us our answer there. What about after 3 months? Well, that would be 100, 1.01 to the third power, because again, it's monthly interest being compounded. And of course, 12 months, what would you get there? Yep, 100, 1.01 to the 12th. So you should go back, double check that you've gotten those answers by just plugging in the Desmos or calculator, and we can keep going. So here you can see I've typed them all in, and we got 101, 102.01, 103.03, 112, 68 for all of these different answers, right? Well, that's cool. So this is just $100, and this is how much you would have if you're getting 1% monthly interest after 1 month, after 2 months, after 3 months, after 12 months. That's cool, but typically, I mean, it happens, right? Some people put $100 in an account, they forget about it, and they never do anything for the rest of their lives. However, that's not a very strategic way to invest. It would be better, right, if we invested regularly. So if we didn't just put money in and then forget about it, but if we put money in every month or every year or every quarter, every paycheck, every day, something like that. That's better because, well, we're investing more money. If we can get a good rate of return, that's going to pay off in the long run. And so the next part of the problem is going to take this information and combine it with our formula here. All right, that's what's about to happen. So here we go. It says, well, what if we invested $100 each month into this account? How much would we have after 12 months then? So that's $100 each month, right? So let's just kind of visualize this. That's $100 first month, $100, right? So month 1, month 2, month 3, $100 the next month, $100 that month, all the way until the 12th month. We would also be investing $100. Well, so we'd be doing $100 each time. They'd be getting interest, right? Because we're assuming the same model. We're assuming the same problem, so 1% per month. Well, so what would that look like? Well, we already have some of these numbers, right? We know that after 12 months, that $100, so this first month, right, would be invested for $100 for 12 months. First $100 would be invested for 12 months. And at the end of that, that would give us 112.68. Month 2, that would be invested for 11 months. Month 3, that would be invested for 10 months. Month 12, that would be invested only for 1 month. And remember, that was $101. And so we need to add all 10 of these amounts up. We need to find all 10 of these amounts, right? We need to raise this to the 11th power, the 10th power, the 9th, 6th, 5th, 4th, 3rd, 2nd power. And then eventually, after we add them all up, we'll get this amount. Or we can understand this formula. And so we're going to go ahead and look at that formula again. Here it is. I'll write it down below. And the formula says the first, or the amount, is going to be equal to the first term times the rate to some power. Now, let's just make sure I'm writing it right. Rate to some power minus 1. All divided by the rate minus 1. Okay, so that's our that's our formula. So all right, so what is the future amount going to be? The future amount is going to be the first term. This is going to be a little confusing, but the first term really means what would the amount be after one period of compounding, right? So $100 compounded at 1% one time, and that's our 101. So we want to treat A1 kind of like our smallest term, or the amount compounded once. So 101. And then what's our rate? Our rate is 1.01 after 12 months. So to the 12th power minus 1 divided by 1.01 minus 1, right? So the R is, remember, 1%. And we write it as 1.01. The N is 12 months because this is happening for 12 months. So we write it as 12. And then again, that A1 is our first term, which is really the number, the amount we're investing compounded one time, right? So that's probably the easiest way to think about that. So that would be 101. So if we have all of that information, we can just plug it into decimal. So literally take, I'll write it one more time. 101. Try to write a little larger for you guys. 1.01 to the 12th minus 1 over 1.01 minus 1. Type that into decimals. You'll get an answer. You can see we got an answer, right? So I've typed this in. Make sure you type it perfectly, just like I have it, the whole thing. Make sure you know how to plug it in, you know how to type that in, and make sure you get the same answer. Now, what is our answer actually going to be? 1,280.93 cents. We want to make sure we round it to a dollar amount. So that's what I've done. And add a dollar sign. And that's it. So if you invest regularly, well, that's going to be a much better payoff. All right. So after 12 months, and remember, this person is investing $100 each month. So that means that they've invested a total of $1,200, right, over 1 year. And so how much have they made? Well, they've made $80.93 just by putting into this account, right? That's what's happening. All right, so that's this whole problem. That's enough to get you started and ready for the lesson. The lesson is going to continue, or the homework's going to continue. You can see I'm going to briefly put examples A and B, and then I'm going to switch it to example C, so you can write that down too. So example A says use example 1 to determine the amount after 10 years if 100 is invested each month. So you're doing the same thing as here, same numbers, same stuff, same initial amount. So 101 is going to be there too. And this is after 10 years. So how many months would that be? Because remember, we're talking about months for that example one problem, right? How many months would there be in 10 years? 120, right? So that's the number you're going to be using. Example B, Tim, it's investing 5,000 each year. So this is each year. Average is 8.7%. How much would he have at the end of 10 years? What about 20 years? So same formula, make sure you find how much is it after 1 year. That's your initial amount, remember. And for example, C, Laura invests $50 a month for 30 years, averaging a monthly return of 0.81%. Remember, make sure you understand that's 0.81%. How much will she have at the end of those 30 years, right? So make sure you get these guys down and get working. Reach out with questions you guys have about this.